Good morning everyone. So we're going to continue with the topic of algebraic proof, and we're going to continue with the further maths topic basically on algebraic proof. Now again, the main thing that we've actually got is odd is 2n plus 1, even is 2n. One thing I would actually like to add from the questions that you were doing the other week is that if he actually asks you to prove that any two odd numbers, prove one of them as 2n plus 1 and say the other one as 2m plus 1. A lot of you, when you were doing the Dr. Frost maths, you were doing 2n plus 3. You are proving it, but you are proving it from the same n value, so maybe pick it for a different value of and a different letter, which in this case is 2m plus 1. So you've got 3 levels of proof, as you can actually see here. So the first one is verify. So verify, let's have a read through what it actually is. So verify is at this lower level verification, all you have to do is substitute a number into the result to show that it works. So say for example, substitute the number 5, does it work, yes or no? Next one, at the middle level, which is show. So at the middle age, you have to show that both sides of the results are the same algebraically. And the hardest level is the proof. It says at the highest level, you have to manipulate the left-hand side of the result to become the right-hand side. The following example demonstrate these 3 different procedures. Okay, so we're going to go through this example together. So for this question here, we're going to go through the different proofs here. Okay, so first one has got verify that the result is true. So because it says it's verify, all they actually do, they simply try the number. So they put the value of n equals 5 when they tried it. Substitution, 12 equals to 12. Part B, it says so that the result is true. So for part B, what they've actually done is they've expanded this side, they've expanded the right hand side, and they ended up having 1 equal to each other. Okay, this is because he actually was asking to show. But if he's asking you to prove, yeah, you don't move from one side to the other. So it says prove. So what they've done is they've expanded this, they've collected the like terms, and then instead of actually expanding the second, the right hand side, they've actually factorized the left hand side in order to prove that is equal to the right hand side. So that is how they would actually do the proof question. So that is the 3 different levels of proof. Right, so these are the questions I want us to be actually trying. So what is? But let's try one example. Half the sum of any 4 consecutive numbers. So consecutive means one after the other. So 2n, 2n plus 1, 2n plus 2, 2n plus 3. It's always odd. So sum. So if I add them together, I get 8n plus 6. So 8n plus 6, and I want half of that sum. So if I divide this by 2, I get 4n plus 3. Well, 4n is always even. So therefore, plus 3 will make it an odd number. Nice and simple. So another tricky question I would say is question 6. Okay, T represents any triangle in numbers. So what do we know about triangle in numbers? Well, so let's have a look. These are what triangular numbers are. So we've got 1 dot, 3 dots, 6 dots, and 10 dots. So what is this sequence? So I'm going up in plus 2, plus 3, plus 4. So therefore, plus 1, plus 1. So this is actually a quadratic sequence, so let's actually work it out. So you've got a value of 2, 2a is 1. So a must be 1 over 2. 3a plus b is 2. So therefore, 3 over 2 plus b equals 2. b equals 2. Take away 3 over 2, so which equals to 1/2. A plus b plus c must be equal to 1. So therefore, 1/2 plus 1/2 plus c equals to 1. So c must be 0. So this means that the quadratic sequence is a half n squared plus 1/2 n plus 0. So this is what the sequence is for the triangular numbers. So how can we use that? Well, t must be of the sequence 1/2 n squared plus 1/2 n. So I want to prove 8t plus 1. So it's going to be 8 times what we just worked out plus 1. So it's 8 halves n squared plus 8 halves n plus 1. So therefore it's 4n squared plus 4n plus 1. So if we were to actually factorize this, it's actually 2n plus 1, which is 2n plus 1 all squared, which is always a squared number. So this is how I would actually produce something like that. Now feel free to try these questions and pause the video. Hear the answers also for these questions for yourselves. Any questions you've got on it, please don't hesitate to actually contact me. Thank you.